Two lines can relate to each other in one of three ways. Two lines can be parallel, they can be perpendicular, or they possibly might meet each other at some oblique angle in which they would neither be parallel nor perpendicular. Parallel lines, this is the geometric symbol for parallel lines, have the same slope. You can see that illustrated on the pair of blue lines that we have graphed there. Perpendicular lines, illustrated by this upside down T, have slopes that are negative reciprocals. That means they are reciprocals of each other and opposite in sign. And again, perpendicular means at a right angle to. So on example 10, we want to write the slope-intercept form. So let's pause right there and remember, slope-intercept form is mx plus b. So I'm going to keep that in mind as my goal. For the equation of the line through ordered pair negative 2, 4, that is A, parallel to, and B, perpendicular to the line given by 2x minus 4y equals 7. Notice that one is in general form. So in order to write the equation of the lines that are parallel and perpendicular to this given line, I need to know the slope of this line. So let's take our line, the given line, from general form and rewrite it in slope-intercept form. To do that, remember, we isolate y. So I'm going to begin by subtracting 2x from both sides, and it's convenient to put it in front of the constant, so we'll call it negative 2x plus 7. Then we'll go through and divide each term by the coefficient of y, which is negative 4. When we simplify, we end up with y equals, our coefficient here is negative 2 divided by negative 4, which reduces to 1/2 x, and we can write that as minus 7 over 4. So the important thing to recognize here is that the slope of our given line, we can identify it as the coefficient of x, is 1/2. So the slope of our given line is 1/2. Now let's write the equation of the line that is parallel to this given line. Well, if a line is parallel to this given line, that means its slope must be the same because parallel lines have the same slope. Also remember, we're considering the line that passes through the ordered pair negative 2, 4. So here we have the slope of the line and a point that the line contains. So we can begin writing the equation of the line in point slope form. Remember, this is y minus y1 equals m times x minus x1. Plugging in our information, y1 is 4, that's the y coordinate of our given point. M is 1/2, x1 is negative 2. So we're going to subtract a negative 2, which ends up being plus 2. So there's the point slope form of the line, but remember we want the slope intercept form. So what we need to do next is distribute our 1/2 to break up these parentheses. And we'll have y minus 4 equals 1/2 x plus 1. And then we're going to add 4 to both sides. So we have 1/2 x plus 5. So this is the line that is parallel to the given line. Now let's write the equation that is perpendicular to the given line. Well, a line that is perpendicular to the given line, now remember our given line has a slope of 1/2. So the slope of the perpendicular line is going to be the negative reciprocal. 1/2 is positive, so we know the slope of the perpendicular line is going to be negative. It's also going to be the reciprocal of that given information. So if the slope of our given line is 1/2 and we flip that over, we're going to get 2. So 1/2 and negative 2 are called negative reciprocals. And again, it has to pass through the ordered pair 2, 4. So with our point slope formula in view, we'll plug in our specific information. y1 is 4. M in this case is negative 2. We have x minus x1, x minus negative 2 gives us plus 2. Distributing our -2 throughout the parentheses, we have y minus 4 equals -2x minus 4, and adding 4 to both sides and combining like terms, looks like we end up with the equation y equals -2x. Now the next example is similar, but it's actually going to be quite easier than example 10. We want to write the equation of the line through ordered pair 3, 4, that is A, parallel to, and B, perpendicular to the line given by x equals 2. So our given line is x equals 2. Notice it only has one variable, so we know it's either going to be vertical or horizontal. Recall that the form for a vertical line is x equal to a number. So we know that this is going to be a vertical line. We could make the observation that its slope is undefined. With that in mind, we can easily write the equation of a line that is parallel to this given line. Now, a line that is parallel to a vertical line is itself vertical. And the form for the equation of a vertical line is always x equal to a constant. We want it to pass through ordered pair 3, 4. Notice the x coordinate of that given ordered pair is 3. So the equation of our line is x equals 3. So x equals 2 is vertical, x equals 3 is vertical, therefore they are parallel. Let's see if we can write the equation of the line that is perpendicular to x equals 2. A line that is perpendicular to a vertical line is itself horizontal. The form for the equation of a horizontal line is y equal to a number. We know that this horizontal line must contain ordered pair 3, 4, but we're interested in the y coordinate, which is 4. So the equation of our perpendicular line then is y equals 4. So y equals 4 is perpendicular or at a right angle to the vertical line x equals 2. And just for review, let's make the observation that the slope is 0. Now, with the same criteria in mind, we can also compare pairs of lines. So on example 12, we want to determine if the following pairs of lines are parallel, perpendicular, or neither. In example A, both of our equations are in slope-intercept form. This is really convenient because we can easily identify the slope. Remember, slope-intercept form is mx plus b. So the slope of our first line here is -2, and the slope of our second line, remember it's the coefficient of x, is +2. So they are opposite in sign, but they are not reciprocals. For that reason, they are not perpendicular. Also, because they're not identical, we can rule out them being parallel as well. So in this case, we could say that those two lines are neither parallel nor perpendicular. On example B, we have two lines in general form. We need to identify the slope of each line. To do so, we need to isolate y in each equation in order to get it in slope-intercept form. So working on our first equation, I'm going to subtract 3x from both sides. This gives us -3y equals -3x plus 1. Then we'll go through and divide all three terms by -3. Not forgetting that last term. So this gives us y equals -3 divided by -3 is +1, so that term just becomes x minus 1/3. So the slope of this line, remember we identify it as the coefficient of x, the slope of our first line is m equals 1. Now we'll do the same thing with our second line. We want to isolate y. So we can do that first by adding 3x to both sides. So for our second line, we have 3y equals 3x plus 7. We'll go through and divide all three terms uniformly by 3 to obtain y equals 3 divided by 3 is 1 times x plus 7/3. So the slope of this line, which we identify as the coefficient of x, is also 1. Since these two lines have the same slope, then it must be the case that they are parallel. And for our last example, we have one line in slope-intercept form and one in general form. If we look at our first line, we can observe the slope of that line, given by the coefficient of x, is negative 2/5. For the second line, we have to rewrite it in slope-intercept form by isolating y. And we can begin by adding 10x to both sides. So that would give us 4y equals 10x plus 3. To isolate y, we need to divide by 4, and we're going to apply that uniformly to all three terms. So we end up with y equals 10 over 4 reduces to 5/2 x plus 3 over 4. Remember, the coefficient of x is the slope of this line, so the slope of this line is 5 over 2. So if we compare the slopes between the two lines, notice they are opposite in sign and they are reciprocals. Therefore, we can conclude that these two lines are perpendicular. So parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals.